In this lesson, we are going to be learning about the properties of quadratic functions. So the first form that we're going to talk about is called standard form. Okay, standard form is written as y equals ax squared plus bx plus c. Okay, so a, b, and c are real numbers. Okay, and a cannot be equal to 0. Okay, otherwise then when we multiply by x squared, it would become 0. Okay, so some examples that you might see would be like y is equal to 2x squared plus 4x minus 7. Okay, so here we have a, b, and c. Okay, you might also see them written as something that's just like y equals x squared plus 3. Okay, and you might be wondering, well, where is the bx? Okay, so that's just 0. B is allowed to be 0. Okay, you might also see it another way where it could just be something like y equals 5x squared. Okay, so what that means is that b and c here are 0. Okay, the only thing that cannot be 0 is a. So the simplest form of a quadratic function is called the parent function. Okay, this is an example of a parent function where it's just y is equal to x squared. Okay, the graph right here shows the parent function. Okay, so whenever we plug in a value for x, we square it and out comes y. Okay, so for example, here we have like 1, 1, negative 1, 1. The shape of the graph is called a parabola. Okay, so we kind of talked about this when we were graphing in the introduction. They create a parabola. Okay, so somewhere that you might see this in real life would be, for example, like if you were maybe shooting off fireworks, okay, and you wanted to know like the velocity per second. So you're shooting it off and it's coming back down, which is creating a parabola, okay? Or like you're throwing a ball up into the air and it's coming back down. It's just some examples of when you might use this, okay? All right, let's look at the first part of properties. So you can fold a parabola so that the two sides match exactly. Okay, so they're a reflection of each other. Okay, this property is called symmetry. Okay, so when you fold it, they fold exactly on top of each other. The line that this creates, that they fall on top of, is called the axis of symmetry. So then we have two other vocabulary words in this section. The highest point of the parabola is called the maximum. Okay, so the maximum right here, this would be called the maximum, the highest point. Okay, then we also have the minimum point of the parabola, which would be a parabola that looks like this way, that's opening here. We have the minimum. The lowest point and the highest point, depending on what kind of parabola it is, the point that I just showed you is called the vertex. Okay, and this is actually on the axis of symmetry. So let me draw a line with a different color to show you the axis of symmetry. Let's use green. Okay, so here, if I fold it, comes straight down through here. Okay, so see how the vertex point goes through the axis of symmetry. All right, in the next part, we're going to try to identify what each vertex is, and then we're going to decide if it's a maximum or if it's a minimum. All right, so we know that the vertex is right here, and we want to figure out that that point is negative 1, 1. Okay, so because it's the lowest point here, this is going to be a minimum. Okay, on the next one, we know that the vertex is right here, which is the highest point, and this point is -2, -1. Okay? And it is a maximum because it's the highest point. All right, can you pause the video for a moment and try the next two on your own? Okay, so what you should have got for the next one was the vertex is here with the point of 1, -3, and we see that it's the minimum. The next one, our vertex, is at the point 2, 3, and it's the highest point, so it is going to be a maximum. Okay, so now moving on to part B. So if any parabola y equals ax plus bx plus c, okay, which we just said is the standard form, if a is greater than 0, so a positive number, the parabola opens up. Okay, so if it's greater than 0, it's going to open up. If a is less than 0, the parabola is going to open down, which looks like this. Okay, so let me just go back to the first one. Opening up, we have a positive. Okay, so here x is just 1. It's a positive number. It's opening up. Okay, so here when it's opening down, it's when y is a negative number. So when y is -1, it's going to open down. Okay, this is a negative x squared right here. All right, then moving on to the next section, we want to know, well, what are the properties of graphing y is equal to x squared? Okay, so you do see a little bit of a pattern. So the parent graph, okay, which we remember that this is the parent graph, the most simplest form, is reliable. Okay, so we can kind of memorize the pattern. So if we look at these three graphs, we can see what the pattern is going to be. Okay, so by looking at the pattern here, we can see that from the vertex, we're going out 1, up 1. Okay, the next time we're going out 1, up 3, out 1, up 5. Okay, so it's kind of going where we're adding 2 each time to when we're going up. So let's check for here. So out 1, up 1. Out 1, up 3. Out 1, up 5. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, so we can kind of see the pattern when we're using x squared about how the pattern changes. Okay, so in this part right here, it should just be over 1, up 1. This is what I was just saying, over 1, up 3, over 1, up 5, and if we continued on, it would be over 1, up 7. Okay, so we can see that it's going up by 2s. All right, so that I'm going to stop right here for part 1. So basically what we talked about were some of the properties for the quadratic functions in the standard form.